All right, this gives us two equations and says there's a solution, x and y, to this ordered pair. The ordered pair xy is the solution to these two equations. What is the value of y? Now remember, when they ask us for anything other than x, which we just kind of solve for by default, you want to write it down, because the most common wrong answer to these problems are whatever x is when they really wanted y. So we want to solve for y. All right. Now, we can't work with two equations, right? We got to figure out how to smush them together to get one equation. And I know the traditional thing to do is we would solve down for x in one equation, shove it into the other equation, solve for y, then plug it into the other equation and figure out what x is. But that takes a long time. So there's nothing wrong with that. It just takes a lot of time. So there's an easier trick on the SAT, which I call smush the equations together, which I realize is not a technical term, but that's what I want to end up doing. Is there any way I can smush these together to make some variable fall out, specifically the x variable, because I want to end up with y's? I've got negative 3x and a positive 4y, right? There's nothing, that's not going to fall out on its own. But you know what? If I could get these guys equal to 12, then they would fall out. One's positive, one's negative. So if I could multiply the whole thing of this by 4, and if I multiplied the whole thing of this by 3, then you'll see what will happen. So let me take that top solution, or that top equation, and multiply through by 4. So I'm going to get negative 12x plus 16y is equal to 16. And now let me multiply through the bottom equation, multiply through by 3. So then I'm going to get 12x minus 9y is equal, 3 times 0.5 is going to be 1.5. Now look at this. When I add these two equations together, my x's drop out, right? Negative 12x plus 12x is 0. Negative 16y minus 9y is going to be 7y. And then 16 plus 1.5 is going to be 17.5. Cool, look at this. I've got my y. Now I just need to figure out what it is. So 17.5 divided by 7. Non-calculator section, so let's think about it. 17.5 divided by 7. 7 goes into 17 one time, right? 14 left over. Or it goes into one time. Sorry, goes into it 2 times. And then that's 14. And then I subtract the 14 from the 17.5 and I get 3.5 left. So this is 2 and 3.5 over 7, or another way to look at that is like, wait a minute, 3.5 is half of 7. So this is, another way to say this is 2.5. So 17.5 divided by 7 is 2.5, and you can go back the other way to make sure you did it right. 2 times 7 is 14, half of 7 is 3.5, 14 and 3.5 is 17.5. All right, so y is equal to 2.5. And let's go back and reread it. What does it want to know? What is the value of y? That is what we solved for. The answer should be 2.5. So you can either bubble in 2.5 or you could also bubble in 5 halves. Either one works. And that's the right answer. So what's the takeaway? The takeaway is when you have two solutions, can you smush them together in some way so that one variable will drop out? And sometimes you need to massage them. Most of the time, you just need to fiddle with one equation. In this case, we had to mess with both of them. One of the reasons this is a hard question, in order to get one variable to drop out. But this smushing together equations is a faster way to solve them.